Bones has been on fire lately. Bones not only asking the best questions about the moon, but now he started thinking about the Earth. Good job, Bones, considering he doesn't have a brain. He's doing great. He wanted to know, how does the Earth move? Okay, since this is where we live, I guess we should know something about how the Earth actually moves and how does that affect us here on Earth? And it affects us a lot. Okay, now the Earth is constantly moving. It is changing positions, and we can predict which way it's moving and where it's going to be when. Okay, so the Earth moves in two different directions. Number one, it rotates. That means it's spinning on its axis, like a car tire spinning on its axis or spinning a top. Okay, it just spins, it turns. Okay, so that's one way that the Earth moves. It's spinning. Another way that the Earth moves is called revolution. Notice, this is the same two ways that the moon moves: rotation and revolution. Now, revolution means that the Earth is going around something. What is going around? Bones? What's the Earth going around? It's in the middle of our solar system. That's right, the sun. The Earth revolves around the sun. The sun does not revolve around the Earth revolves around the sun. So the Earth spins on its axis and revolves around the sun, and that causes lots of different things to happen every single day here on Earth that affects our lives every single day. So let's talk about what affects rotation and revolution, rotation spinning, revolving going around, has on Earth, and how does it affect our daily lives. Okay, we're going to start off with Earth's rotation. Okay, that's the spinning of the Earth. The first thing you have to know is Earth is on an axis. Okay, it's like if you took a pole or a post, you took the North Pole, you took the South Pole, and you drilled a hole through the middle of the Earth, and the posts connect each other. Okay, one big long rod going through the Earth. That axis is tilted at 23.5 degrees. Okay, now we're going to come back to that soon, but you have to remember, very, very important, put that number in your memory bank, that the Earth's axis is tilted at 23.5 degrees. Okay, very important. Now, it takes the Earth approximately 24 hours or one day to rotate one time. Okay, and it's doing it in a counterclockwise rotation. Because it's rotating counterclockwise in 24 hours, this is why the sun rises in the east and sets in the west. Okay, so rotation is very, very important. Okay, we have evidence for this. We know this. It's very, very common knowledge that the Earth is rotating in a 24-hour day, which is why we have a 24-hour day. Okay, one time in a counterclockwise position, 23.5 degrees. All very important facts in order to know about how the Earth is going to affect us. Now, what does that cause? Bones, what does that cause? Let's check it out. Rotation causes day and night. Okay, so as we are spinning, okay, we all know daytime comes, then nighttime comes. Daytime comes and nighttime comes. That's because as we're spinning, okay, we're spinning to being in our half of the world being in front of the sun, and then we spin and the sun is hidden from us. And then we spin back in front of it, and then we spin back behind it. Okay, so we're just spinning, and if we're facing the sun, it's daytime. If we're facing away from the sun, it's nighttime. Okay, facing towards the sun, daytime, facing away from the sun, nighttime. This is what causes the sun to rise in the east and set in the west. And it also causes objects to appear to be moving in the sky. Okay, it appears that the moon is moving in the sky. It appears that stars are moving in the sky. It's actually us that is moving underneath it. Okay, we are moving relative to the stars that we're looking at because of Earth's rotation that's happening on an axis of 23.5 degrees in a 24-hour period. Okay, so it appears that objects are moving across the sky, but it's really us that's moving underneath it. Now, as I said, the Earth appears to rise in the east and set in the west. So you can see that here we are spinning this direction, okay, counterclockwise, all right, the opposite way the second's hands goes on a clock, counterclockwise. So here we have a picture of how night is coming, okay, so we're starting to spin out of the sunlight. Remember, half of the Earth is always lit up by the sun, half is always in darkness. just like the moon. Half is always lit up in the sun, half is always in darkness. Same with the earth. Half is in the sun, half is in darkness. So in this picture here, you can see that nighttime also, let's say nighttime rises in the east and sets in the west. So here's New York, here's Florida, and we are spinning again counterclockwise this direction according to this picture, and eventually this will go into dark. This also is one of the big reasons why we set up the time zones the way we did. Remember, we have 24-hour time zones that go around the earth to match the 24-hour day. Mind blown. I know yours is 2 bones. Okay, so let's take a look at this a little bit more. So now, according to this picture, where would the sun be, Bones? What do you think? Where's the sun? Is it back here behind us? Or is it on the other side of the earth from us looking at this picture? What do you guys think? That's right, it's on the other side. Okay, so we're looking at, if we were looking at this right now, we would be in the full moon position, let's say, looking at the earth, and the sun is on the other side. Well, eventually, the United States, we're going to turn, okay, we're going to turn and we're going to go back into the sunlight when we go around the other side. So we're in the full moon phase right now, looking at the earth, and the sun is on the other side. So the other side of the world, it's daytime, while on this side of the world, it's nighttime. But remember, half of the earth is always lit up with the sun, half of it is always in darkness. That never changes. So let's take a look at this. September 9th, 2008, at 6 a.m. We know where we are. Here's the sun. We're going to line up the sun right here, right in the middle of this chart here of the earth. Okay, right in the middle of the map. So this is 6 a.m. Eastern Standard Time for New York. So it's still a little dark out. So remember, in early September, we're coming back to school. It's still a little dark out at 6 a.m., but it's about to be sunlight. This is the area, okay, that is exposed to the sun. Everything else around the world is in darkness. If we continue to go, so we are going to be rotating. What direction are we rotating again, Bones? Counterclockwise. Very good. We're going to be rotating counterclockwise. So the sun appears to move, but it's not the sun that's moving, remember. Who's moving? That's right, the earth is moving. So now the sun, notice, is over here a little bit. All right? That's because we've spun counterclockwise that way. So now notice, it's 8 a.m. 8 a.m., when you go back to school, it's light out. Look, it's light out on the East Coast. It's still dark in California. Kids are still sleeping. Go back to time zones. We can figure out what time it is in California if it's 8 a.m. in New York. Okay? I'm not going to do that now, but you can do it. Now, if we continue to go, 10 a.m. Notice where the sun is lined up. We are continuing to spin underneath the sun. Okay? The sun is not quite overhead. Okay? And look at the area of the earth that is lit up now and the area in darkness. As we continue to move on, 12 o'clock. We know if it's 12 o'clock p.m., the sun should be directly over our head. And look where the sun, here's the sun, look where it's lined up. It's lined up directly over our head. So at 12 p.m., the entire United States is in the daylight, okay? Where this part of the earth over here now is in darkness, okay? So they're facing the full moon side of the earth, while we're getting to more of the new moon side of the earth. We're on the side of the sun. As the earth continues to spin or rotate underneath it, okay, it appears that the sun is continuing to move across the sky. The sun is not moving. Let's not forget that. Remember, we are rotating counterclockwise underneath it, okay? So this is all lit up, and it's nighttime over here for the rest of the earth. 4 p.m. in September. The sun is over here. Okay, moving away. We can see nighttime starting to creep in New York on the East Coast where we are. But look, it's over here. The sun is starting to light up over here. Remember, the earth is spherical. It goes around. Okay, it's not a flat map. All right, it goes around like a globe, like a ball. All right, so it's starting to light up over here as it moves along. We are continuing to rotate counterclockwise. Notice 6 p.m. It's dinner time. New York is starting to get dark. Okay, New York is starting to get dark because we're spinning underneath it. And on the other side of the world, it's starting to become daytime again. This is their morning. We are going into nighttime. This side of the earth is going into morning, while this side is totally in darkness. So, how long does that take? The revolution of the earth takes 365 and a quarter days, or 1 year. This is why every 4 years or so, we have a leap year. It has to make up for that extra quarter of a day, okay? So every once in a while, we're going to have 366 days in a year. Now, the Earth revolves around the sun in a elliptical pattern. I mean, it's almost circular, but it's not quite. It's actually oval, okay? And it moves to different positions around the Earth, around the sun, which is going to end up giving us our seasons, which we're going to talk about soon. What you need to know about the Earth's revolution is it takes 1 year. It takes 1 year to happen, and we have 4 seasons: winter, spring, summer, and fall. The craziest thing about learning about the seasons, which we're going to do soon, is the Earth is actually closer to the sun in the winter and farther away from the sun in the summer. Mind blown. That shouldn't make sense, but it does, because the Earth revolving around the sun is not the only factor that involves what seasons we get, okay, or what season it becomes, all right? And we're going to talk about that soon. So, what do you need to remember? The Earth rotates on an axis that's tilted at 23.5 degrees in 24 hours, 1 day. It also revolves around the sun in 1 year, or 365.25 days, okay? And it goes around an elliptical orbit. So those are the 2 ways the Earth moves around the sun, which is very similar to the moon moving around us. Next time, we'll talk about the seasons.